Okay, we're not here yet, but anyway, back in the day, way back, well, this is an old TV too, but way back in the day, like turn of the century, um, they loved playing with these cathode tubes. They loved playing with these vacuum tubes where they'd heat up a coil, a magnetic coil, heat it up, then fire electrons through here. Because look, this gets the negative node, then the electrons go whoosh, they go flying through the anode part, okay? And then these electric fields are set so that they deflect the electron of where it's supposed to go, all right? So that's how you get a picture on your television back way back. Now this is all done with solid state physics and things. So you get a nice flat screen and HD and all that. But we're getting way ahead of ourselves. So here we go. Like poles attract, strength of the magnetic field. Okay. Closer they are together, the stronger the field. A magnetic field. Remember, all fields create a force on something. All right. So gravitational fields create forces on the masses of things. Gravitational forces has no effect on light because light has no mass. Photon has no mass, but light is an electromagnetic field, so you can bend light in magnetic fields and things like that. All right, um, and it's an electromagnetic field. Electrons put out. In other words, when we create an electromagnetic wave, like your radio waves and TV signals and things like that, which are light waves coming to us, we can adjust the signal and all that. And we'll get into that in chapter 20. I'm getting way ahead of myself. So here we go. Here's your first, well, I'll be darned, an equation where the B field is equal to the force over the charge times the velocity of the charge. Or the B field is known as the force, which is in newtons, is equal to Q times V times B times the sine. It's the perpendicular component. That's why we're doing all that right hand rule. It's the perpendicular component of the B field that causes the thing. Because here's the actual real thing. It's Q times V cross B, the vectors. And whenever you take the cross product of vectors, that's VB sine theta. Okay? All right. It's the perpendicular component that causes the force, that makes the force. That's why if they're parallel, force is equal to zero. All right? So there's your equation. There's your equation. Okay? Now, yeah, that'll do. So let's take a look. It's measured in Teslas. B field is measured in Teslas. An interesting thing to do would be to see how charge times meters per second divided by kilograms meters per second squared. Why is that given us test how, so you can see the kilogram, the gram is still at the base of the magnetic field in the amperes. Here you go. In general, the particle is moving at an angle to the field. The force is perpendicular to both the velocity and the field. It's perpendicular to both the velocity and the field. So x, y, z coordinates. That's what makes this a little bit tricky. There's your right-hand rule. Gives the direction of the force. And then we'll talk about the applications on, I'll probably give you, we'll kind of take a little quiz over this part, and then we'll look at the mass spectrometer, which I think is the next thing. Yeah. So that gets a little dicey. I'd like to do that in person. All right. Out here. We are done.